Hello everyone, welcome to iQuanta. In today's video, we have a set of remainder questions for you. First of all, we'll learn the concepts that we'll apply in those questions and then we'll be solving them. Now, I've already told you that we'll be putting a good set of questions every day on our YouTube channel along with video solution. So if you really like the solutions, you really like the initiative, please respond by subscribing to our YouTube channel. Okay, so let's see the questions that we have today. This is the first question that we have: 50 to the power 51 to the power 52 mod 11. Mod simply means you have to find out the remainder when this particular number is divided by 11. Now whenever you see questions where a lot of powers are involved, huge powers are involved, you'll first think about the Euler theorem. So let us talk about the Euler remainder theorem first. So we apply Euler only when we have huge powers involved. That should be our first thought. It might be a case that always Euler is not applicable even in the power questions, but the first thought should be Euler whenever you have a huge power. Now the conditions for Euler are: the first condition is the dividend and the divisor must be co-prime. I hope you know what is co-prime. Whenever two numbers have HCF equal to 1, then they will be called co-prime, otherwise they are not co-prime. So dividend and divisor must be co-prime. And another condition for Euler should be huge powers, so that we can reduce that power using Euler theorem. So these are the two main conditions. It's not necessary that the divisor should be prime or the dividend should be prime. We should simply have a huge power and dividend and divisor must be co-prime. So now when we see the first question over here, we have 50 to the power 51 to the power 52 mod 11. So we can see that the dividend here is a multiple of 50 while the divisor is 11. So 50 to the power anything will always be a multiple of 50. So we can simply find out the HCF of 50 and 11. Definitely it will be 1. So that means dividend and divisor are co-prime. We can apply Euler theorem over here. Now how to start applying Euler theorem? We'll always find out the Euler of divisor. So Euler is written as E of divisor. Divisor here is 11. So whenever you have to find out the Euler of a prime number, it will always be 1 less than that. So 11 will have Euler 11 minus 1. That means 10. But what if you are finding out the Euler of a non-prime number? For example, if I tell you to find out the Euler of 12, then in that case, first of all, you will be writing down the prime factorization of 12, which is 2 square into 3. I hope this is clear. Now how to find out the Euler of 12? You will simply write down 12 first, then you will write down 1 minus 1 by the first prime factor, which is 2. So 1 minus 1 by 2, this bracket will be closed. Then you will find out 1 minus 1 by 3 because 3 is the another prime factor of 12. So 1 minus 1 by 3. So now you will solve this. This will become 12 into 1 by 2 into 2 by 3. 2 cancels, we'll get Euler of 12 equal to 4. I hope this is understood. Similarly, if I tell you to find out the Euler of 25, you know that 25 is 5 square, so you'll simply write down 25. Only prime factor of 25 is 5, so 1 minus 1 by 5. This gives us 25 into 4 by 5, which gives us 20. So Euler value of 25 is 20. I hope you've understood how to find out the Euler of a number. So this was step 1, to find out the Euler of divisor. Then the second step is you have to find out power mod the Euler value you just found out. So it is 10 over here, so power mod 10 should be the next step. So power here is 51 to the power 52 mod 10. So you know how to find out the answer in this case. We'll simply divide this 51 by 10, remainder will be 1 because 51 mod 10 is 1. So 1 to the power 52 mod 10, it again becomes 1. So after finding out power mod Euler, we are getting this new number, this new remainder, which is 1 over here. So this will be the new power now. So now the question becomes 50 to the power 1 mod 11, and now this is very easy to find out. 50 mod 11, 50 to the power 1 is 50. 50 mod 11 is 6. So I hope you've understood this. Whenever you have huge powers, use Euler. Now similarly, let us solve the second question. So the second question is 50 to the power 51 to the power 52 mod 22. So first of all, we'll be checking if the divisor and dividend are coprime or not. So 50 and 22, are they coprime? No, they have HCF 2. So that means we cannot apply Euler over here directly. In that case, what we'll do, we'll try to break this divisor into its factors. So 22 can be written as 2 into 11. So whenever we break the divisor into its factors, this theorem is called CRT, which is also known as the Chinese remainder theorem. I hope you are familiar with this. I just took these questions to tell you how to differentiate between questions and how to check which particular theorem to apply in a particular question. Now in CRT, you have to break the divisor in such a way that the numbers being multiplied are coprime. What does this mean? I just broke this 22 into 2 into 11. So here 2 and 11 are coprime. That means yes, I have broken the divisor into product of two numbers which are coprime. So then I'll be moving forward. What if the divisor over here was 20? Now you know that there are multiple ways to write down 20 as a product of two numbers which are 2 into 10. Then you can also write it down as 4 into 5. But which pair to use while applying CRT? We cannot use this pair because 2 and 10 here are not coprime. They have HCF 2. But 4 and 5 here, they are coprime. So that means this pair will be used to apply CRT. So the first step is to choose or to break down the divisor into multiplication of two numbers that are coprime to each other. And if there are multiple pairs, you have to choose that pair in which the numbers that are being multiplied, they are coprime. So I hope you have properly understood this. Now when you break this divisor into product of two numbers which are coprime, after that you have to find out remainder by both these numbers. That means you will find out 50 to the power 51 to the power 52 mod 2 and same with mod 11. So let us find out 50 to the power 51 to the power 52 mod 2. We can simply see that 50 is a multiple of 2, so the remainder here will directly be 0. Now how to use this 0? Since we divided here by 2 and the remainder is coming 0, so that means we can write it, or this 50 to the power 51 to the power 52 in form of 2a plus 0, where a is any number. In fact, a should be a positive integer over here. So this is the first equation that we get on dividing the dividend by 2. Now we'll also divide this by 11, 50 to the power 51, 52 mod 11. We just found it in the previous question. We were getting answer 6. So this will be equal to 6. So how to write it down? The equation formed will be, since we were dividing by 11, so it will become 11b plus 6. Why am I using a over here and b over here in this equation? Because it is not necessary that a and b will be same. So you always have to ensure that different variables must be used over here. Now from where am I getting this equation? I hope you are familiar with the very old equation, which is dividend equal to divisor into quotient plus remainder. So that is what I have done over here. The divisor was 2, so I have written 2. The quotient will be a, so I have written a over here. The remainder was coming 0 in this case, so I have written 0. Similarly for mod 11, the remainder was coming 6, so it is 6 over here. We were dividing by 11, so divisor will be 11 and quotient will be any number which I have taken as b. So now after this you have to equate these two equations. 2a plus 0 will be equal to 11b plus 6. Now you have to find out values of a and b so that these two equations become equal, and the value that you will get after equating them, it must be less than the divisor, because the remainder should always be less than the divisor. So if you are getting your remainder greater than the divisor, you are wrong, or you have committed a mistake while solving. So if I take a equal to 3, then this LHS becomes 6. Similarly, if I put b equal to 0, then the RHS becomes 6. So that means you have to look for values of a and b such that LHS becomes equal to RHS. So at 6, these two are becoming equal. That means the remainder should be 6 over here. So answer to second question will also be 6. Now if we come to the third question, we have mod 33 over here. 50 and 33, they are again co-prime, and we also have a huge power over here. So that means we can apply the Euler theorem. So let's try to solve this question. Now there are two ways to solve this question over here, either by Euler or CRT can also be used. Why? Because we can break down the divisor into two numbers which are co-prime. So if I use CRT, 33 will be written as 3 into 11. Why? Because 3 and 11 are co-prime. We'll find out remainder by 3, we'll find out remainder by 11, then we'll equate and find out the remainder. While if I use Euler over here, I will have to find out the Euler of 33. 33 is nothing but 3 into 11. Then 33, 1 minus 1 by 3, then 1 minus 1 by 11. So we'll get 20 ultimately. So that means we'll find out power mod 20. So then a new number will come up. So this is becoming quite long with the Euler method. So let us try to apply CRT. We already know 50 to the power 51 to the power 52 mod 11. We have already calculated it. It will be equal to 6. So we can write down 11a plus 6. Then if we divide this number by 3, 50 to the power 51 to the power 52 mod 3. First of all, we can simply reduce this. We know that 51 mod 3 equal to 0. So 50 mod 3 will be equal to minus 1. I hope you know the concept of negative remainders. So we can write it as minus 1 to the power 51 to the power 52 mod 3. Now we know that minus 1 has an odd power because 51 to the power 52 will definitely be an odd number. So we'll be getting minus 1 to the power odd. I can simply write it as mod 3. Now minus 1 to the power odd will always be minus 1. So mod 3. Now minus 1 mod 3 will be equal to 2. So that means on dividing 50 to the power 51 to the power 52 mod 3, we are getting 2. So we can write it as 3b plus 2. We'll have to equate these now. Now if I put a equal to 1 over here in the LHS, I'll be getting 17 for a equal to 1. And if we put b equal to 5, I'll be getting 17 in the RHS. And in this case, I have my remainder less than the divisor. So that means 17 will be the answer in the third question. So I hope a lot of your doubts would have been cleared by solving these three questions. I told you multiple cases in which multiple remainder theorems were being used in the same question. It is not a case that you cannot use more than one remainder theorem in a question. You might have to use Euler first to reduce the power, then you might have to use CRT in the next case. So there can be questions where you'll have to use more than one remainder theorem in questions. If there was any doubt regarding this video, if there is a confusion at any point, please comment. We'll come up with few more good questions on other remainder theorems as well. Apart from that, you have to practice. Now you'll only understand this after a very good practice, that which particular theorem to apply in a particular question. If you practice well, I'm telling you, you'll be able to solve the initial steps of a few questions or even the whole questions orally. You won't even need a pen and paper to solve these questions. So we'll come up with another question and its video solution tomorrow. Subscribe to the channel if you want daily updates. Soon we'll also come up with few LRDI sets as well. Keep practicing. Thank you.